In this video, I'm going to show you that the power set of the natural numbers has the same cardinality as the subset of the real numbers, the open interval between 0 and 1. All right, so what I mean here by the open interval 0, 1, if you think back to calculus class, you got x, you got y, so open interval 0, 1 is all the real numbers between 0 and 1. There's infinitely many numbers in there, all kinds of numbers in there. Lots and lots and lots and lots of dots in there. All right. So the way that I'm constructing this function uses some things we've already developed in Functions 5 lecture. One of those from the previous video is that you can represent all decimals in binary. So these are all binary representations. These are all binary representations of the numbers of all the different, so in infinitely many things in this column here, I can't list all infinitely many of them. But every decimal, every real number has a unique decimal representation. So each of these numbers has a unique decimal representation. I've just converted those from the normal way that you write them using base 10 to base 2. So they're written in binary here. Okay, and then on this side we have the infinite bit string representation of subsets of the natural numbers, as we've seen many times before. All right, and notice that they're basically the same thing. If you look at, say, this second row here, they're exactly the same thing. So what I'm doing is I'm just sending or associating, or you think of the function sends an infinite bit string representation of a subset of the natural numbers to the binary decimal that has 0 point that thing. So I guess, for instance, let's see, an example is do. Let's say 2, 3, right? We represent this, or let's see, 0 is not in there, 1's not in there, 2 is in there, 3 is in there, and so on, right? So that's the infinite bit string representation, all zeros here, forever and ever and ever after that, right? Okay, so we send this thing over to 0.001100. And that's it. There's really not much going on. You just add a decimal point to the end and a 0 there. And since each of these are unique on both sides, then this is a one-to-one and onto function. Oops. Right, each of the subsets of the natural numbers has a unique bit string representation. That's that. So everything so everything on this side is different. Everything on this side is different, so that's one-to-one. And you can see from what I have here that there's not going to be any D and E's. And so it's a bijection, and so they have the same cardinality.